Hello, welcome back. Today, let's try to solve another Leetcode problem. 2516, house robber 4. So this problem is basically we are giving an array. So inside of the numbers array, the numbers means how much property at this house have. For example, the index 1, this house has a property of 2, and index 0 have a property of 2, and index 1 have property of 3, and index 2 has a property of 5, and last index has a property of 9. But the robber cannot rob the neighboring houses. It means if the robber robbed the property of 2, it cannot rob the 3. It has to be 5. Yeah. And if it robs 3, it cannot rob 5 again. It has to rob a number 9. Yeah. So this key number means the minimum number of houses the robber will steal from. So this K means the robber will steal at least K houses. For example, this numbers 2, 3, 5, and 9. If the robber at least steal 2 houses, it may rob 2 and 5, or it may rob 3 and 9, or it may rob 2 and 9. But what is the final result? The final result is the minimum of the maximum of those numbers. So this is the maximum, it's 599, but the minimum will be 5. Yeah, actually this is a minimax problem. For such kind of a problem, we need to check the length of the ring first. It is 10 to the power of 5. We have to use the binary search to solve it, because binary search may be n log n. Yeah, the time complexity is okay for such problem. Why we can use binary search? Because we can use binary search to guess. Yeah, if we already know the numbers, and how can we check from the array? Yeah, so the binary search is just used to guess. If we know the minimum of numbers, for example, is 0, and the maximum maybe 10 to the power of 9. Yeah, for binary search, maybe the L equals to and R equals to 10 to the power of 9. This means we can use binary search to guess what is the middle between this minimum and maximum. It may be some number in between, and then we're gonna use the binary search to guess. If we guess a number, maybe it is a 10. Yeah, it's just an example. We're gonna use the example 1. Yeah, maybe my guess is a 10. So what about the 10? Is that possible? So I can rob the first house, and then I cannot rob the second house because they are neighbors, and then I can rob the third house. So for the first house, 2 is less than and equal to 10. Yeah, so this means it is okay. So what about I rob this one, 5? Yeah, it means it's still okay. So the numbers, how many houses are robbed? It is 2. 2 is at least more than and equal to this K. Yeah, so this means this number is a possible result, but it is still too big. So what about 5? Yeah, because binary search, normally we take half of the number. What about the 5? So we're going to try this number 5. So 2 is less than and equal to 5. It means that we can rob this house, but we cannot rob 3. So we have to rob the next one, 5. 5 is still more than less than and equal to this threshold 5. Yeah, so this 5 is just a number we guessed. Yeah, we guessed this number, it should be 5. So it is still a possible result. So 1 plus 1, we have 2 numbers, is more than and equal to K. It means 5 is a possible result. So the result should be 5 at the moment. Then, because we use binary search, maybe the next made number may be 3 or 4, but it must be less than 5. What about number 4? Just an example. So 2 is, maybe next number we're gonna guess a 4 to guess it. Is that possible? 2 is less than 4. Yeah, it is one result. Now we're gonna find the next. 3, is that possible? It's not possible because 3 is a neighbor of 2. What about 5? 5 is not a neighbor of 2, but 5 is more than this number 4, it means it's not possible. It means the threshold, my guessed number, the guess is too small. I have to increase it. Maybe I increase it to 5, and then I get my result. Yeah. So for such problem, I think the most important is what do we think? How we transform the Minimax problem to a binary search. Actually, the binary search is the brute force. Yeah, because we use binary search to guess, and inside the array, actually it is a brute force. But here, it used the greedy idea. Yeah, for example, we're gonna take another example. Maybe the numbers will be, let me take 1, 3, 7, and 5. Yeah, maybe we have 4 numbers. This means the property of each house. So our threshold is still 5. Yeah. So normally for us, we're gonna check one by one from the beginning to the end. So this is greedy. We check the first one. It is 1. It is possible. And then the second one, its neighbors, not possible. The third one, it's not possible because 7 is more than 5. What about the last one? It is possible because 5 is less than or equal to 5. So we have a 2. Yeah, because here the k equals to 2. Yeah. So here this means we got a number of 2 and we find a result. But what if the array is not like that? What if we are not going to check like 1, 3, 7, and 5? Maybe we just gonna check this is 3 first. Is that possible? Yeah, we can do like this. So 3 is less than or equal to the threshold 5. We cannot drop 7. And what about 5? 5 is less than or equal to 5. It means 3 and 5 is also a possible answer. But 1 and 5 already included this 3 and 5. This means the greedy actually works from 1 to 5 always have a bigger distance than 3 and 5. This means if 3 and 5 is possible, then 1 and 5 must be possible. Yeah, this means we can use the brute force. This means we can use the greedy to check from the first number to the last number. If it is more than the threshold, this number 5, it means we're gonna count as one result. Finally, we're gonna check how many numbers. If our numbers is more than the value of k, it means we meet the conditions. Yeah. Now let me write the code and explain in my code why we can use this kind of a method. First, I'm gonna keep the example array here. Yeah, I'm gonna use this example here. And then write the functions. So for my template to solve such problem, normally I'm gonna define a check function. And for the check function, I'm gonna use a threshold and a value k. So k is from the main capability function. So I'm going to take this k. And here I'm gonna put a pass. Yeah, and finally I'm going to finish this check function, but I'm going to write the main function first. So the L and R pointer should be the minimum of nums and maximum of nums. So why? Because here we use the max with any kind of numbers, and here finally we use the minimum. So the minimum and maximum. So what is the result of the minimum and maximum? So it must be the minimum of the numbers to the maximum of numbers. So this is why we can use L and R pointer to the minimum of nums and the maximum of nums. Then we can directly use the binary search. So this is my template for binary search. So then I'm gonna have a m equals to L plus R minus L divided by 2. Then I'm going to check. So my check function is m with this k. So if my check function is true, this means I guessed a number. This number is m. This guess is the threshold from here. If this number is possible, it is true. It means I'm going to guess another smaller number. Yeah, because the bigger number is true, I'm going to guess if a smaller number that is possible or not. For example, my first guess is number 10. 10 is true. What about I guess a number 5? 5 is also true. What about I guess number of 4? 4 is not possible. So finally, I'm gonna return this number 5. Yeah. So here I'm going to use the tag. So if the tag mk is true, this means it's a possible result. So here, before that, I'm going to define a variable result. It will be started from 1 because the numbers is more than or equal to 1. It doesn't matter, but I will give a 1. So the result should be the tag with the result should be, yeah, if this is true, so the result should be m. And the R pointer should be m minus 1. Yeah, because we are guessing a bigger number, if it is true, it can be a smaller number, even meet the conditions. We can find any two numbers less than the threshold. Yeah. Otherwise, so the L pointer should equal to m plus 1. So this is the template for binary search. And finally, we're gonna return the result. So here is the sub-functions for this tag. We just need to check if we can find such numbers less than the threshold, such number of houses less than the threshold. Now let's just I'm gonna define is robbed. It means this house is robbed or not, because we cannot rob two neighboring houses. So I have to use a sign variable. So I will use is robbed and house. This house means how many houses I will rob. So is robbed from the start, it will be false, and the house will be 0. Now I'm going to loop through the nums. So for n in nums, I'm going to check. So if is robbed, so if this house is robbed, so I'm not going to rob it again. So I'm going to use a continue. But before I'm going to use continue, I'm going to set this variable is robbed to false, because if this is robbed, it means this is true. So for the next house, it will be false. Elif, so this means is robbed is false. Yeah, actually for the for loop, the first one, the is robbed is false. I'm going to go to the elif. I just need to check if this number n is less than or equal to the threshold. Yeah, if it is less than and equal to the threshold, it means this house can be robbed. Yeah. So if this house can be robbed, what are we gonna do? Yeah, let me think. I just lose my mind. Let me think. So if this number n is less than and equal to the threshold, yeah, it means we can rob this house, and our house needed to plus 1, because from the beginning the house is 0. It means we're gonna rob this house. Yeah, the house should plus 1, and we're gonna set this sign variable. So the is robbed should be equals to true. Yeah, because from the beginning it is false. Yeah, it is false if I rob this one. So for the next one, is robbed is true. It means I cannot rob the next neighboring house. Yeah, if I robbed 2, I cannot rob 3 again. So this is why I gonna set is robbed to true. So for the next one, here is true, and here I cannot rob the, yeah, it will continue. But is robbed will set to false. It means I can go to this one again. Yeah, so this is basically the function for check how many houses I can rob below the threshold. Now I'm going to return this house. If my house is more than and equal to k, this is because here said, yeah, we are also giving an integer k. This means the minimum number of houses we'll steal from. So it means at least the robber will steal k houses. So the houses would be more than and equal to k. Yeah. So this is basically the entire function. Yeah. The idea is we're going to use a binary search. After binary search, we're going to use a greedy idea to check how many houses we can rob. If the number of the houses is more than equal to the threshold, is more than equal to this k. Yeah, but for checking the numbers, we're going to use this threshold. Yeah, if the property is less than and equal to the threshold, because threshold is just a guess. And now let me run it to check if it really works. So for in nums, yeah, it works. Now let me submit it to check if it can pass all the testing cases, and then I will analyze the time complexity. Yeah, as you can see, it really works, and it's like 100%. Yeah, basically it is okay because binary search is very fast. So now let's analyze the time complexity, because here basically this is the main function. Here is the binary search. So the binary search, the minimum nums and maximum of nums, it is 10 to the power of 9. Yeah, let's set this to the biggest number is m. Yeah, so this is log m. And here is the array, length of the array. Let's set the length of the array is n. So the time complexity is m times n times log m. So m is the maximum number inside the array. Actually, it is r minus l. Yeah, but we will guess the maximum number is 10 to the power of 9. So this is m. And n is the length of the array. Because how many binary search we used? We used, yeah, how many binary search used? We used log m. And how many, and how many loops? It is log m loops we used. And for each of the binary search, yeah. So for the binary search, it is log m. But inside the binary search, there is a check. So the log m should times n. Yeah. So the check is on. So this is why the time complexity is n times log m. Yeah. This is the entire tutorial for today. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like this. See you next time.